Welcome to Chapter 20, Hypothesis Test for Proportions. Now, as you start organizing your notes for this chapter, I want you to pay attention to you're not going to have as many formulas as you have in the last chapters. So we will be spending a couple of days in class going over examples and how to use the information in this chapter. So for now, as you organize your notes, there are some key points that I will tell you you must have in your notes, but it's going to be some listening, pausing the video, maybe summarizing what you've heard. So it's a little bit different than the other videos you've seen. Okay, and these next two chapters, you'll see, will go together. Okay, so first of all, what is a hypothesis test? Remember that we don't believe in miracles. We don't know exactly what is going to be happening. If we notice something rare happening, meaning that the probability of it happening is rare, then something we assumed from the beginning has to be wrong. Okay, we notice something rare happening, then if it happens, then we know that what we assumed from the beginning is wrong because the rare thing occurred. Okay, so a hypothesis test proposes a model for the world, and then we test if it's possible or not. So this is going to be the process. You're coming up with a hypothesis, and then we're going to see do we think we have enough information to say the hypothesis isn't true, or do we say we go with our hypothesis because we don't know if it's going to be perfect or not. Kind of goes with the confidence interval from the last chapter we've been talking about. Okay, so here's an example we're going to be talking about. So ingots are pieces of solid metal that are made from molten steel. They need to be solid. They can't have any cracks in them. And there's one plant that about 20% of the ingots are cracked. So a new process is developed, and they tested it on 400 ingots. And only 17% of them have cracks in it. So then the question is, do we actually solve the problem? Or is that just a variation and nothing really changed? So did we just pick a different sample? And you've heard us, we've talked about that a lot in class. Okay, so do we know that we actually fixed it, or maybe not? Okay, all right, so the conclusions are this. So we can conclude that the new process works, yay, and the new proportion of cracked ingots is less than the original 20%. So that would be a good thing. Or we conclude that seeing 17% is nothing unusual, especially since everything varies, and then we have no reason to say that the 20% is wrong. Okay, so option 1 is we fix the problem. Option 2 is, oops, that was an anomaly, not really going to happen. Nope, we still haven't fixed the issue. Okay, so those are the two options. Okay, so with a hypothesis, or with a hypothesis that has been proposed, that's going to look at, we propose a hypothesis as a model to the world, then we look at the data, and two things can either happen. So the data is either consistent with the model, or it is inconsistent with the model. So we can conclude that the model is incorrect. Okay, so here's more information about that. So what you want to write in your notes is if the data is consistent, and then the rest of this, in your own words probably. So if the data is consistent, then the data that is consistent with the model lends supporting that hypothesis. It doesn't prove the hypothesis, so make sure we get that, okay? We're not proving the hypothesis, so not proving the hypothesis. We simply can't argue against it since the data was consistent with the model. Okay, so remember, we're never proving anything. That's going to come up later. Okay, or the data is inconsistent. So if the data is surprising to us, then we start wondering, I wonder if my hypothesis is actually right or not. So what is surprising? Seeing an event happen that has a very low probability of happening. Okay, seeing an event happen that has a very low probability of happening. And then we're on to something. So if it's a low probability of happening, then we say, oh, I think that hypothesis might not be right. We start saying, no, I don't really think so. That right there is, in a nutshell, what we're going to be spending the rest of the year on. Okay, so do we say the hypothesis, we think we're on the right track, Or nope, we found some data that says nope, it's not. It's surprising, so we can't really trust that hypothesis anymore. Okay, so we'll go back to that in just a bit. So the next thing is p-value, and you'll hear that a lot. Okay, so we can measure how likely an event is to occur, and that probability is called the p-value. Okay, so how likely an event is of occurring. Okay, so if it's rare, then we're surprised and we doubt the hypothesis. If it's not that rare and it's likely to happen, then we can't doubt the hypothesis. Let me show you the next slide, and this might be something that you want to copy down into your notes. Okay, so on a normal curve, okay, so more likely observation is in this area. Once we get into the tails, we start to say, ooh, that's very unlikely. I don't really think that's going to happen. And then at some point or somewhere, we put a p-value, and that can change. Okay, so what is that p-value? And if it's above that, we say, oh, it's probably unlikely. And if it's below that, we say, oh yeah, we expected that to happen. Okay, so right here again, it's the probability of an observed result assuming that the null hypothesis is true. Well, null hypothesis, we're just about to get into that because you might be wondering, what is that? I haven't heard that word before, or those words. Okay, so this definitely is in your notes, null hypothesis. It is H sub 0 is how we refer to the null hypothesis. So it specifies a population model parameter and it proposes a value for that parameter. So the parameter is going to be some value, some situation that we expect to have happen. So the way that I've always thought about this too is the null hypothesis, if I did nothing, that's what we assume to have happened. So the experiment that we've tried, what has always happened in the past? That's what your null hypothesis is. So nothing has changed. That's what we expect to have happened. That's what always has happened. Okay, so the null hypothesis, I kind of think of it as nothing exciting. Nothing has changed. Okay, so if the p-value is high, then we saw something happen that is likely to occur and is consistent with the null. So here are the magic words. We fail to reject the null hypothesis. We never accept it. We fail to reject it. Okay, so we don't have enough information to say, hey, wait a second, I think something else might be going on. So we fail to reject it. We didn't throw it out. We kept it. But the way that the way the statistic says is we fail to reject. Okay, so if the p-value is very small, then we saw something surprising and the data is inconsistent, then we can go ahead and reject the null hypothesis. So those are your two options, okay? So please make sure you have that down. So if the null hypothesis, nothing surprising happens, then we fail to reject the null hypothesis. If something surprising happens and we're gonna change, then we reject the null hypothesis. Okay. So the alternative hypothesis has H with a subscript A. Okay, so it's what we believe could be true based on the data that we saw. So after we've done our thing with the experiment, then this is a statistical number that will show us, wait a second, if this is what's happening, then we don't believe in that null hypothesis anymore. Okay, so we're going to use this language here, and we're going to reject the null hypothesis. We don't accept the alternative hypothesis. Okay. All right, so back to the ingots. So we saw 17%. How rare is that when we're supposed to see 20%? All right, so the null hypothesis is that our p-value, is equal to 0.20. The alternative hypothesis is that p is going to be less than 0.20. So we want to find out what's the likelihood that that's going to be happening. Okay. All right, so what do we need to do to find that out? Well, so we have an expected value. That's the probability, that 0.20. Standard deviation, we figured that out. So we have P times Q divided by 400, and we get 0.02. So now we need a z-score, okay? All right, so what is the probability of seeing less than 17%? So from negative 99, the z-score didn't show up on here. The z-score, what we figured out was it ends up being negative 1.5, okay? Because we have 0.17 minus 0.20 divided by the standard deviation 0.02, and that equals negative 1.5. Okay, so now we're going to look on our normal curve. So our normal CDF, negative 99 to negative 1.5, and we get 6.7% of the time that we're going to see that 17%. Well, that doesn't seem quite that out of the ordinary. 6% of the time it's just going to happen, and that's really not that rare. The other way you can look at it is it's only 1.5 standard deviations away from the mean. It's really not that, it's not that far away. Okay, so probably just variance. All right, so we fail to reject the null hypothesis of 0.20. So because we never proved, we don't know that what the true proportion is. We just know in that one place it's 0.20. So we just can't say that it's wrong. You know, after all we saw, it wasn't that weird, assuming that the 20% is correct. So we fail to reject that null hypothesis. Okay. All right, so here's another way to look at this with a confidence interval. So 0.17, and again, we could have looked at this with 0.20, but let's look at it with the 0.17, okay? So if we just look at the confidence interval of, this is our p hat, and 95% confidence, and we looked at all of this from before. Here's our interval. So 95% of the time, we expect to see between 13% and 20.68% of cracks, or right between those two, we expect to see what the true proportion is. Okay, so the interval contains the 20%. So really, it lands right in there, so we can't say that it's wrong. Okay. Okay, a one proportion z-test. So very similar to what we've been doing. Okay, so the conditions are the same for the z interval. So we find the z statistic, assuming that the null is true, and we find the p-value. So our p hat minus what that original value is, and the standard deviation with the p hat. Okay, and we're going to take p times q divided by n. So this is all the same. You're finding a z-score, you're finding the standard deviation. Okay, so then you have to wonder, well, okay, do I look above or below the z-score? And you really just have to read the problem to determine what that what the null hypothesis is going to be and what the alternative hypothesis is going to be. Okay, so again, or not again, you don't care if it's above or below. It just can't be the null. Okay, it can't be the same as that. So then it's a two-tailed hypothesis. So it depends. You either have a one-tailed hypothesis or you have a two-tailed hypothesis. And then here's a picture for you. So one or two tails. So here's our two tails, what it could look like. It's either below that or above that, 0.23. Okay, or we're just going to look below, which was where this was the alternative hypothesis was that it isn't 0.20. Okay, it's either above it or below it, but it just can't be it. And here with the null hypothesis, the p is less than 0.2. We're going to be spending quite a bit of time in class on Thursday and Friday, and probably a little bit on Monday as well, talking more about this. Okay, so this is my last slide here. Okay, so 4 steps, and we will work on this in class. So you have the hypothesis, you have a null hypothesis, and you have an alternative hypothesis. So what is my hypothesized value? And then what do we think if we end up rejecting the null? What are my other options? Okay, all right, and then you create a model, and we're going to use this one proportion z-test. There are other models to use, but for now, that's what we're going to be using. This is going to be a big decision that you have to make. And then you do all the calculations, and then you decide in your conclusion, which is what this says right here, it got cut off. Do I fail to reject the null hypothesis, or do I reject the null hypothesis? And then you explain why. Okay, so lots of information. I realize that the goals are understanding the null hypothesis and the alternative hypothesis and the differences between those. And the key words being that you fail to reject the null hypothesis if nothing unusual happens, and you reject the null hypothesis if something unusual happens. And then we're going to look at the tails and the p-value. Okay, all right, that is it.